Science helps us understand Earth, nature, and the universe. Science also helps us apply our knowledge to develop technology, which in turn help us solve problems and improve the condition of human society. So, by the help of science, ginabuligan kita sani para maintindihan naton kung ano nangyayari sa aton palibot, nano ang nangyayari sa universe, sa nature, nano kay may nangyayari na mga phenomena like parang sudden change of the weather, yung mga mainit na panahon tapos biglang umulan, mga ganon. Then it also help us develop new technologies para mapadali, technologies na makabulig sa mga tao po or sa aton society. Next. And
Hello, good afternoon po, sir. Online na po, sir, si John Ray.
Sige na, continue. Andiyan na ba si John Ray? Sige na, continue na.
Opo, sir, adi na po, online na.
John Ray.
ano po pa na sir, in January po pa na gina-present ko po.
Online na po siya.
Online na siya, pero wala pa siya sa ano. Please advise him, please.
Ano na lang po, siya na lang po sir, ma-continue sir, kay sa iya po pa na gina-present ko yan na.
Please prompt me, please, or kindly inform him to join immediately. We are running out of time. Sayang yung time natin.
Good morning, everyone. This is the slides presentation of Group 1. In Chapter 1, Section 2, Science is a Process. We're going to explain how science is different from other forms of human endeavor. And the word endeavor means it relates to the word field of study or expertise. We're going to identify the stats that make up scientific methods also. And we're going to analyze the scientific thought as changes. That scientific thought changes as new information is collected. And we're going to explain how science affects society. And before we dive in, we're confronted by the question asking why it matters or why science. We have been given a fair and justified answer. Why science matters? It says that science helps us understand the earth and the universe, also the nature. Science also helps us apply our knowledge to develop technologies, which in turn help us solve problems and improve the condition of human society. In short, science helps us live a better and easy life and understand more about certain things. You might have your argument about this statement, but I hope at the end of this lesson, you will be answered accordingly. It says that art, architecture, philosophy, and science are all forms of human endeavor. As I said lately, the word endeavor relates to the word field of expertise. Although artists, architects, and philosophers may use science in their work, science does not have the same goals as other human endeavors do. The goal of science is to explain natural phenomena. Scientists ask a question about natural events and then work to answer those questions through experiments and examination. Scientific understanding moves forward through the work of many scientists who build the research of the generation of scientists before them. Now the behavior of nature is understandable, and they expect that similar forces in a similar situation will cause similar results. But the forces involved in natural events are complex. For example, changes in temperature and humidity can cause rain in one city, but similar changes in temperature and humidity may cause fog in another city. These different results might be due to different or differences in the two cities or due to complex issues, such as differences in climate or differences in geological locations. Let's just say that studying natural systems are very complicated, which means that the future behavior of natural forces can be anticipated. Because of science, we're able to make technology of machines that help us understand more about this field of science. So if scientists understand the forces and materials involved in a process, they can predict how that process will evolve. By drilling down into the ice sheets or glacier and recovering ice from ancient times, scientists are able to determine the past composition and behavior of the atmosphere. What the climate was like when the snow fall, and how the size of ice sheets and glaciers have changed in the past in response to different climate. Because natural systems, however, this situation pala was mentioned in the past lesson when the scientists was or those who study the scientists in the picture, for example, sir. Can I see the picture? The scientists in the picture, for example, are studying ice cores in Antarctica. Nako, sir, dito gyapon po, sir. This information can help scientists learn more about the climate changes in the past. Because natural systems are complex, as I've said lately, however, a high level of understanding and predictability can be difficult. To increase their understanding, scientists follow the same basic processes of studying and describing natural events. This is called, or more likely addressed as, and this is the highlight of my discussion. Scientific methods over time. The scientific community has developed organized and logical approaches to scientific research. These approaches are known as scientific methods. Scientific methods are not a set of sequential steps. Rather, these methods are guidelines to scientific problem solving. Question. The second is forming the hypothesis. The third one is testing the hypothesis, and the last were drawing conclusion. Okay, the first one was ask a question. For many years, we cannot deny the fact that every discovery comes from a simple question, and that question lead to another question that leads to another complicated one and hard to be answered that leads to scientific discovery, experiments, and investigation. But before that, scientific methods often begin with observation. Firstly, before you ask a question. Well, observation is a process of using the senses of sight, taste, touch, hearing, and smell to gather information about the world. When you see thunderclouds forming in a summer sky, you are making an observation. And when you feel cool, smooth, or polished marble, or hear the roar of a river rapids, you're making observation. We are actually doing this unconsciously, maybe even every minute. We are observing things around us and sometimes without knowing that we are doing it. And observation often lead to questions. Like for example, what tornadoes to form? Or why is oil discovered only in certain locations? Bakit hindi dito sa Pilipinas? Bakit hindi doon sa China? Or bakit hindi doon sa Central America? What causes a river to change its course? What causes some plants to grow faster than others? Simple questions such as these have fueled years of scientific research and have been investigated through scientific methods. And after the observation happened and the question has been asked, you will now form your hypothesis. Next slide, sir. Once a question has been asked and basic information has been gathered, a scientist may propose a tentative answer or answers that they are expecting, which is also known as hypotheses. Hypothesis, the definition of hypothesis, or the plural form hypothesis, is a possible explanation to solutions or solutions to a problem. Hypotheses can be developed through close and careful observation. Most hypotheses are based on known facts about similar events. One example of hypothesis is that plants that are given large amount of sunlight will grow faster given than the plants given a small light given a small observing and how or where the plants grow. We can see it for ourselves too. If we see a plant which are the same species, we place one inside the house and the other one put it outside your doorstep where sunlight is visible. We can observe how the plants react to different environment. We will also see which one will grow faster. And that is when we form a hypothesis. And after that method, the next one will be the testing or test the hypothesis. After hypothesis is proposed, it is often tested by performers. You have to do some investigation to prove that your claim or statement or your hypothesis is factual or makatotohanan. An experiment is a procedure that is carried out according to certain guidelines. And the factors that can be changed in an experiment, and in this lesson, we're taught that there were two types of variable while or during the test or testing your hypothesis or during your experiment. The first variable was the independent variables, meaning these are the factors that are changed by the person performing the experiment. The other one, the dependent variables, are variables that change as a result of a change in the independent variable. Also, in most experiments, only one independent variable is tested. To test how sunlight affects plants, a scientist would grow identical plants. The plants would receive the same amount of water and fertilizer, but different amounts of sunlight. Thus, sunlight would act as the independent variable, and how the plants would react would be the dependent variable. The person who performs the experiment has the power to manipulate the independent variable, which actually talks about this amount of sunlight that will be controlled by the plants on how they receive it. Shortly saying, the dependent variable only depends each changes to the independent variable. And the independent variable also are being manipulated by the person performing the experiment. The plant will grow faster or slower depending on how much sunlight it will absorb. And also, in most experiments include a control group. A control group is a group that serves as a standard of comparison with another group to which the control group is identical except for one factor. Like what had been mentioned earlier, let's just say that a control group is a plant, similarly nurtured, but in one factor, which is how they are being exposed to the sunlight. And the person who performs the experiment will make a comparison and will see what's the difference that two experiments makes in comparison. In most scientific experiments are controlled experiments.
I will just say something, some important points, talking about or testing the hypothesis. It is because when you reach perhaps in, or yeah, when you're already in service, this is actually important things that you have to master, especially that in science, we're actually promoting the solid science process skills. And this thing is very much important. You know that science is deemed a boring subject, and it is through the conduct of an experiments investigatory project that we can expose our students, and in order for them to at least enjoy the subject. And talking about the testing of hypothesis or test the hypothesis, these variables, you have to really master these things: independent variables, dependent variables, and a control group. So what are these things? When we are talking about independent variable, as made mention by John Ray, that in an example of, we are actually looking into perhaps the growth and development of this plant. You have the setup A and setup B. So if we are going to look into the independent variables, the factors that we can actually look into with the setup that we have prepared, itong example, itong letter A and letter B, ang magiging independent variables natin or the factors that are actually changed, ng nagkakandak of that experiments, that would include the
sun-
intensity or
sunlight.
perhaps the concentration of sunlight, ano? And the change or what made possible on the growth of the plant, either yung color niya, color of the leaves, the length of the stem, those are the dependent variables which are actually affected by the factor or the range of sunlight or the concentration of sunlight, which we refer to as the independent variable. And a control group is actually, as made mention by Mr. Manlapas, it is the standard, or it will serve as our comparison, either comparison to that of what really happened to the range of sunlight as we exposed our setup A and setup B, in order for us to at least serve as the point of comparison, ano? Ito yung magiging basehan natin. Kung, for example, ilagay natin yung setup A natin sa malilim lang, ilagay natin sa at a certain amount of sunlight, or I mean at a certain level, kunyari sa oras na lang, like sunlight at 9 o'clock, 10 o'clock, and 12 o'clock. Alright? So those are the important things that you have to master in testing hypothesis. Okay? Sige, continue, Mr. John Ray.
The zero gravity experiment shown in figure 3 is a controlled experiment. This is an example of controlled experiment. Astronaut Shannon Lucid observes wet plants as part of a controlled experiment in orbit around Earth.
Yeah. Thank you, Mr. Manlapas, for sharing to us actually this one important phenomenon, or actually natural observations. I mean, this is actually unique, ano? Thank you for sharing this to us. That what have made performed by Shannon Lucid, ano? That the wet plants, tiningnan niya, nasa labas ito, nasa outer space siya, observing or performing, looking into the variables if wet plants
Yes po, sir.
would react,
Zero gravity.
Yeah, nasa zero gravity talaga siya. Kung talagang mag-grow siya in the absence or with the presence, I mean, of artificial sunlight.
But also there's the other way around. If the experimental results differ from what was expected, or bang nag-iba or dili amo ani mo gi-expect sa imong experiment, and result expected and unexpected results lead to new questions and further study. The results of scientific inquiry may also lead to new knowledge and new methods of inquiry that further scientific aims. Even though the conclusion has been made or has been taken out, it only stop in one checkpoint, but will further go on deeper to understand more and to help us learn more about certain things. And that's the end of my discussion. The next slide will be discussed by Miss Eileen Delio.
Opo, sir.
As part of, or sa conclusion part or ending discussion and part discussion ni John Ray, yeah, that is true, class. We have to remember at the course of your experiment or your investigation, and you were able to arrive at a conclusion that it disproves, dinisprove niya, it does not validate your hypothesis, you have to actually report that one. Kasi ang nangyayari, perhaps baka itong nagagawa natin usually, that nakita natin that the result of our observation or our experiment does not favor our hypothesis, minamanipulate natin. So that's the reason why, as future science teacher, dapat ito yung maging practice natin. When we allow our students to perform experiments and they were able to elucidate or to generate conclusions that disprove or that does not favor their hypothesis, allow them to draw their conclusions objectively. Kailangan ipakita talaga nila yung pinaka-conclusions na na-arrive nila or ano yung lumabas sa kanilang results, because as made mention, will lead to another form of hypothesis. So we can encourage again our students to formulate or to conduct another, perhaps we have not requiring them, though they are going to submit the output already or their technical report perhaps, or the research work, but that is another avenue, another avenue for them to at least be engaged into conducting an experiment. Kailangan i-allow natin yon. And with that, we have to remember, class, when our students arrived at disproving, dinidisprove, hindi siya nag-favor doon sa hypothesis, sa tentative explanation nila, we have to allow them to give us the details, to explain further what are those error, what made possible, ano yung mga variables, perhaps intervening variables na nakaapekto doon sa expected solutions sa kanilang problem. Okay? So, kailangan ini-encourage natin yon. Hindi yung baka mamaya, when nakita natin na negative ang naging result ng kanilang experiment or investigatory project, is dinidiscourage natin sila. No, it should not be the case. We have to encourage that matter because isipin natin that will lead to another observation. That will lead to another experiment. Alright? So, by that, may encourage natin, we can actually build the so-called culture of research. Yung magiging, baka mamaya magkakaroon na sila ng love for science. Magugustuhan na nila ang science because it continuously, gaya ng discussion natin previously, it is a continuous process. Our students were able to conclude